Ever get that feeling, when you're looking up at the night sky and it's like, whoa, so vast, so much out there?
Yeah, that sense of wonder. It's pretty universal, I think.
Absolutely. But what we're doing today is kind of flipping that on its head, taking a deep dive into the 9 absolute worst ways to die in space. Because let's face it, the universe can be a beautiful, awe-inspiring place.
But it can also be incredibly hostile.
No kidding. So forget the romantic astronaut dreams for a bit. We're getting real about the dangers out there, the stuff of nightmares.
Right, and it's not sci-fi either. What we're talking about is all based on, solid physics, real astronomical phenomena. We've looked at all these hypothetical scenarios.
But they're totally plausible, which is the scary part.
Exactly. So consider this your cosmic survival guide, though hopefully you'll never actually need it.
Seriously. Okay, our mission today is to break down these space death scenarios, figure out what makes them so deadly, and hopefully do it in a way that, keeps you on the edge of your seat but doesn't fry your brain with too much technical stuff.
A little bit of cosmic horror, but digestible.
Exactly. All right, let's kick things off with number 9 on our list of the worst ways to die in space. Solar flares.
These things are, well, imagine a star having a total meltdown. And I'm not talking about a celebrity Twitter rant. I'm talking a massive burst of radiation and energy that could literally strip the atmosphere off a planet.
That's intense. And we've got a prime example of a star with a serious temper, Proxima Centauri. It's a red dwarf, smaller than our sun, but man, does it have some powerful magnetic fields.
And those fields, they get all twisted and tangled, and that's what triggers these monster solar flares.
One of the sources you sent me mentioned this crazy flare where Proxima Centauri got 14,000 times brighter. Just like that. I mean, how much energy are we talking about here?
It's mind-boggling, really. And the thing is, these red dwarf stars, they're actually way more prone to these huge flares than, say, our sun because of how their magnetic fields work. So picture this. You're cruising through space, maybe heading towards Proxima Centauri, and bam, one of these mega flares hits.
Not good. What happens?
Well, first of all, say goodbye to all your electronics. That initial burst of energy would just fry everything instantly. Your ship, your comms, everything just gone.
Do like a massive power surge, but on a cosmic scale.
Exactly. But it gets worse.
There's more?
Oh, yeah. You've got this massive wave of X-rays and gamma rays hitting you at the same time. These are like super-powered light waves, but invisible, and they go right through stuff. So not only is your ship toast, but your body is getting bombarded with radiation.
Yikes. So what does that feel like?
Well, you probably feel incredibly nauseous, just weak all over. Those are the classic signs of radiation poisoning. And your life support systems, you'll be fried, so you're struggling to breathe.
Not a good way to go.
No, it would only take about 5 minutes of that level of radiation to, completely destroy your vital organs.
5 minutes? That's sick.
Yeah. But there is one slightly less horrible detail, I guess.
Oh.
You probably pass out from the radiation poisoning before you actually suffocated, which, at least spares you from that particular agony.
Small mercies, I guess. All right, so lesson 1 for surviving in space. Avoid volatile stars. Let's move on to number 8 on our list of cosmic calamities. Getting trapped in a gravity well.
This is where things get really fundamental.
Yeah.
Every object in space, even a tiny speck of dust, has gravity. The bigger the object, the stronger the pull. And that creates what we call a gravity well. Imagine like a dip in the fabric of space and time.
And for this scenario, we've got this gas giant called Rock's S42b, which is 9 times the mass of Jupiter. That's massive.
Unbelievably massive. So let's say your ship has a thruster malfunction and you drift too close to this monster. You're caught in its gravity well, and your engines, even at full power, just can't fight that pull.
You're going down.
Fast. And that means you're experiencing some seriously intense G-forces.
Like the kind that make you black out.
Oh, way beyond that. We're talking levels that would crush a human body, no question.
No.
Your blood gets forced away from your brain. You black out almost immediately. But that's not the end of it.
It gets worse.
You're still plummeting towards this gas giant, deeper and deeper into its atmosphere.
So no gentle landing then?
Nope. The atmospheric pressure builds, the friction from moving so fast through the gas, your ship would just break apart.
And you're exposed to what exactly?
A nightmare, basically.
Yeah.
Superheated winds, toxic gases, a chaotic storm that would rip you apart, and there's absolutely nothing you could do about it.
So gravity's not messing around. Okay, well, let's hope our future astronauts have some seriously reliable thrusters. Moving on to number 7. The fiery demise of atmospheric entry. You'd think aiming for a planet with an atmosphere would be safer, right?
Not necessarily. It's actually incredibly tricky and dangerous. Think about it. You're
Yeah.
coming in at like hypersonic speeds, smashing into a wall of gas.
One of the sources mentioned Kepler 22b as an example. It was something like 28,000 kilometers per hour for a hypothetical landing. That's insane.
Yeah, and all that friction from hitting the atmosphere at that speed, it generates an insane amount of heat.
Mhm.
We're talking temperatures over 2,000 degrees Celsius.
Hotter than lava. Even with a heat shield, that sounds risky.
It is. Any little flaw in that shield, even a tiny crack from a micrometeoroid, and that heat transfers to the cabin, you'd be cooked in seconds.
So heat is a big problem, but there's more, right?
Oh yeah. The friction also creates these crazy turbulent forces that can literally rip your spacecraft apart.
In mid-entry, that's not good.
No. You're talking explosive decompression, life support failure, the whole works. It really shows you how delicate this whole atmospheric entry thing is, how precise everything has to be.
Yeah, suddenly every successful landing we've ever pulled off seems like a miracle. Okay, let's shift gears a bit. From fiery re-entry to a danger that's a bit closer to home. Space junk in Earth's orbit. It's number 6 on our list.
You might be surprised by this one, but the area around our planet is getting pretty crowded and dangerous because of, well, us.
We've basically turned low Earth orbit into a giant junkyard, old satellites, bits of rockets, all sorts of debris just floating around.
And the numbers are pretty crazy. Like there's an estimated 9,000 tons of this stuff up there, over 100 million pieces smaller than a centimeter, and over 25,000 bigger pieces.
It's like a cosmic minefield.
Pretty much. And the thing is, this junk is moving incredibly fast, like 8 kilometers per second. That's 10 times faster than a bullet.
Imagine getting hit by something, even something small, at that speed.
It would be devastating. Even a tiny piece could puncture a hull, wreck critical systems.
And there's that whole Kessler syndrome thing, right?
Yeah, that's the worst case scenario. Basically, so much debris up there that collisions start creating more debris, and it just cascades out of control.
We end up trapped on Earth because it's too dangerous to even leave.
Exactly. It's kind of ironic, isn't it? Our own garbage making space travel impossible.
Yeah, a real wake-up call. Okay, let's venture out a bit further now to a place that's incredibly cold. Triton, one of Neptune's moons. It's number 5 on our list.
Triton is this super weird alien place. It's covered in ice that's so reflective it bounces back almost all the sunlight it gets. And since it's so far from the sun, that's not much to begin with.
The average temperature is minus 235 degrees Celsius. That's unimaginable.
Yeah, and even the best spacesuits we've got, like the ones to the Artemis missions, they can only handle temperatures down to about minus 173.
So you're not surviving long out there without some serious upgrades.
No. Now, the interesting thing is, freezing to death on Triton wouldn't be like instant.
Really? Why not?
It's because there's a thin atmosphere, not much, but some. So you wouldn't freeze instantly like in a vacuum. But it wouldn't be pleasant either.
What would happen?
You'd lose heat slowly through radiation. Your core temperature drops, your heart rate slows way down, you get numb, confused. It could take an hour, maybe 2, to fully freeze solid.
A slow, agonizing death. Okay, moving on to number 4, which brings us back to the dangers of small but fast-moving objects. Micrometeoroids.
These are basically tiny bits of space debris, like grains of sand, but they're zipping around at crazy speeds, tens of thousands of kilometers per hour.
We've all seen shooting stars. Those are just bigger meteoroids burning up in the atmosphere. So what makes these little guys so dangerous in space?
The atmosphere is key. When a meteoroid hits the atmosphere, the friction makes it burn up. But in space, there's basically no atmosphere to slow them down. So they stay at those insane speeds, like microscopic bullets.
So it's like a constant low-level threat.
Right. The odds of getting hit are low, but the consequences are high. Spacecraft have shielding, but a direct hit in the wrong spot.
Could be catastrophic.
Exactly. You could get hull breaches, damage to life support. One tiny micrometeoroid could be all it takes.
Okay, so a constant worry. Let's move on to number 3. Rapid decompression, and a particularly nasty side effect called ebulism.
Ebulism is basically what happens to your bodily fluids in a vacuum. If your cabin or suit breaches suddenly, the pressure drops and liquids boil.
Wait, your blood boils?
Yeah. No external pressure means the boiling point of liquids drops way down. So you get gas bubbles in your blood, your tissues swell up. It's not pretty.
How long could you survive that?
You'd probably pass out in about 10-15 seconds from lack of oxygen. And even if you could somehow be rescued, the damage would be done. You're talking complete organ failure, probably within minutes.
It's amazing how quickly things go bad in space. All right, number 2 on our list of space horrors, lung explosion in a vacuum.
This is specifically about what happens if your spacesuit breaches and the air inside escapes really fast.
I'm guessing that's not good for your lungs.
No. The air in your lungs expands super fast because of the pressure difference and basically rips your lungs apart from the inside out.
Ouch.
And then that escaping air can get into your bloodstream, creating air bubbles that can block blood flow to your heart and brain.
So you're talking heart attack, stroke.
Exactly. It all happens incredibly fast. It really shows you how vital a sealed, pressurized environment is in space. Even a tiny tear in your suit can be deadly.
Okay, deep breaths, everyone, because we've reached number 1 on our list of the absolute worst ways to die in space. Spaghettification by a black hole.
Yes. Black holes, the ultimate cosmic monsters. They're regions of space where gravity is so strong that nothing, not even light, can escape.
And the closer you get, the stronger the pull.
Right. Exponentially stronger. And here's the thing. The difference in gravity over a short distance, like between your head and your feet, is so huge near a black hole that, well, you get stretched.
Hence the term spaghettification.
Exactly. You're pulled lengthwise, compressed sideways. It's like being put through a cosmic pasta maker.
Vivid.
There's absolutely no way to survive it. Once you cross the event horizon, that's it. Game over.
The ultimate one-way trip.
Yep. So there you have it. From exploding stars to inescapable gravity wells to the mind-bending horror of black holes, we've covered a whole spectrum of ways to die in space.
And it really paints a picture of just how hostile and unforgiving space is.
Absolutely. It takes incredible technology, meticulous planning, and a healthy dose of luck to survive out there.
It makes you wonder, doesn't it? Knowing all this, why do we even bother?
That's a great question. I think it speaks to something fundamental in us, this drive to explore, to push the boundaries, even when facing incredible danger.
And when you think about how much we still don't know about the universe, all the other potential dangers lurking out there.
It's both exciting and terrifying, isn't it?
Absolutely. But for now, let's just appreciate the courage it takes to venture into space, knowing all the risks involved. It's a testament to human ingenuity and our insatiable curiosity.
Couldn't have said it better myself.